Hi kids, nice to meet you all with another session. I hope all of you are doing great and continuing to be safe. So today also we are here with another exciting session that we are going to work with using Arduino. So as you are all aware of the number of projects that we have been working using the Arduino, today is another cool activity which will be indeed helpful for all of you to keep your treasures, your homes, your lockers safe. So I think by now all of you would have guessed what it is. It is a digital lock or a smart a smart door lock system which helps to keep your homes and lockers really safe at any time from the robbers. As you all know, kids, these days the concern to keep your treasures safe is really important and the concern is really high. So having a system like this which helps your treasures to be protected by password that allows the door to be open is really cool, right? So we are going to make a door lock that opens when you enter your password, and say for example if the password happens to be wrong, then it is not going to open the door of your home or the locker or wherever the treasure is being placed. Also, we will be working with a servo motor which turns back to the position it was in after some seconds. So when you have clicked, when you have given the right, when you have entered the right password, the servo motor um, by its itself, it unlocks the lock and then it comes back to the original position after some time. So again, the system is back to being locked. So this system consists of a module called the keypad. So keypad 4 into 4. This is the matrix that is being involved, 4 into 4, because we have 4 rows and 4 columns, as you all can see. So you all must have heard about this keypad. This, this is an input device which is used to read the keys that is pressed by the user and to process by it. So we also have 3 by 4 matrix keypad, but for this activity, since we are working with Tinkerpad, working with 4 by 4 matrix keypad is really easy. So we have chosen this particular keypad which consists of completely 16 buttons, and a special mention, kids, is that in this keypad the switches are placed between the rows and columns. When any one of the key is pressed, it establishes a connection between a row and a column, right? So for example, say I need to click on number 1, then I have to choose this row and this particular column. So thereby there is a connection between a row and a column if I want to press any key out of all the 16. So this system also does not give us the module does not give us to say what a row is, what a column is. What I mean is all these namings right here, which is R1 means row 1, R2 is row 2, R3 is row 3, R4 is row 4, C1 is column 1, column 2, column 3, and column 4. So all of these we ourselves have to realize it, because it is not mentioned or written down in any of the cable as such. So if you get the hardware, the real system, the real module in your hand, also you would see that there is no label written, but we ourselves have to flip it back, and you would see something like this, and easily you can identify what a column is and what a row is. So let me give you a brief explanation about that, in case if you all are working on the hardware of it, you all can do that part very simply. So kids, you will see number 1, 2, 3, and 4. So columns to this alignment, right, to longer side, where rows will be from your left to right. So when you go to this box, you would see that the connection over here is all connected and then is being aligned to this particular connection and named as row 1. So here also you will see the whole connection. It starts from here and then goes there and then all the way down as row 2. That's row 2. So if you have to see what row 3 is, start all the way from here, go like that and go like that, and you don't go all the way there because it's not the right way, and then you go all the way down so that it's row 3. So likewise you have to figure out what the rows and the columns are. So to dive you all further in, this is like a switch that uh, behaves. When you click on number 1, it makes the connection on. Number 2, it makes the connection on. Likewise, we can see, we can identify 16 number of switches. So when we are working with Tinkercad in our circuit diagram, also we will be using these 8 pinouts from the keypad module, and also we will be working with the servo motor. So for the Tinkercad we will be using a micro servo, and this particular servo arm can turn up to 180 degrees. So since we are using Arduino, we can specifically say from where to where the motor axle has to move. So to go to a particular location, then it's just going to go there. So we have all of these components which are really easy to work with, so which indeed makes our project very easy, right? So this GIF that you are seeing is a fingerprint door lock, as in the password is the fingerprint, but so that is just an overview to you. But remember that what we are making here is not going to get unlocked by a password, but it's going to be not going to be unlocked by a fingerprint, but it's going to be a password. So here is our circuit diagram. It does not consist much of components, but rather a keypad module, 4x4 keypad module, the servo motor, the micro servo motor. We need two LEDs to give indications when the system works, as to say which is at which instance the system is on and at which instance the system is off. So when the system is on, it's going to lit up the green LED, and when the system is off, it is going to lit up the red LED. So what I mean by on and off is the door lock being unlocked and locked. So when the green LED is lit, it is going to be in an unlocked state, and when it's red, it's going to be the locked state. So this is the simple diagram which we will be working soon. Right kids, so this slide is all about the mechanism to show how realistic your project is. How that when all the circuit is made, we can come up with a system like this, which results in the total functioning of your password protected door lock system. When it comes to mechanical systems, it's not only about just the systems being there, right? There is a way for each and every one of the system to function. The applications, depending on the function, depending on the movement that it makes. Same two machines of different types do not move in the same way. So because of these, there are several types of mechanisms that, for example, clutch yoke, the crank and slider, the crank cam. So these are the types of mechanisms being, that are being used widely. So here is a very common mechanism, the peg and the slot mechanism, which works really which works in a very functionable manner. So let me explain you how this system works separately. So this is how the system is represented as of itself alone, but when it is implemented into our project, we can see it as of something like that. When the disk starts the rotation in clockwise, you would see that you would notice that the slot moves quickly towards the right. That is because the peg or the pivot point is exactly very close to the slot at the beginning, right? Even in the picture you could see how close the peg is towards the slot. But when the peg gradually moves towards the bottom with the 180 degree of rotation of the disc, you would see that the slot very slowly moves. So initially the system is in the locked position, and when it is unlocked, you would see that the slider is just going to uh, move away and the fence is just broken. And then when it is locked back again after a turn of rotation, it is going to again get locked. So the unlock and the locking process is totally dependent on how the axle of your motor is moving, right? So it's just simple as that. So to build our circuit, we have to start with the Arduino and the breadboard connections, and also with the micro servo and the keypad 4x4 module, and we have two LEDs as I mentioned, and also a very simple Arduino for this one as well. And we are going to simulate and test and see how it's going to work. So let's get started and go to Tinkercad right away. Now that we have come into Tinkercad, we will go to circuits, create a new circuit. Let's get away from these funny names and have a proper name like Dolok. So for this, just drag and drop all the components that I've mentioned before. So here we can use either of the micro servo that is available on Tinkercad, but we will be using S2309S because the functioning is like better with compared to the other micro servo. So let's choose this. Yeah, so this is it, and let's just assemble it to make sure that it's in proper order. Actually, do not need a breadboard, right? So let's just delete it and just like that. So now that we have twisted the servo motor, let's start making our connections. So let's change this color to green. There it is, green. And let's connect the cathode of this LED firstly to the ground terminal of the Arduino board. And the anode terminal, let's connect to pin number 13. So that also you could just have colors. And the cathode, you take it all the way from here to there so that we can ground it here, because as you can see we don't have enough grounding pins in the digital side of the Arduino board. So let's take it all the way there and color it black, and anode terminal to pin number 12. Right. Now let's start with the connections from the keypad. So starting from column 4, column 4 will be connected to digital pin number 2, column 3 to pin number 3, column 2 to pin number 4, column 1 to pin number 5, and column and row 4, that would be that there is a twist of being connected to number 9, and then it's row 3 to 6, 6 row 2 to 7, row 1 to 8. So now that looks all messy, we'll just leave it. So you can always change the colors so that you could make it easy for you to understand how the connection has been taken place. So let's change the colors. Thank God we have so many colors so that we can choose between them. And let's just leave the others as that. Alignment is really important because when it comes to the coding, it helps us with the proper identification of the pin number, especially for something like this. If it is all in a message, then it is going to be very hard for you when there is an error in the code. So we have completed with that. Now let's go on with connecting the servo motor to the Arduino board. So the servo motor is really easy, connecting the power to 5V. So just right there, and that would be red. Ground would be again to the ground pin right here. So in this board we have used all the main ground pins, right? Yes. And the signal pin is directed towards pin number 11 of the digital. So, right, so this is it with our circuit connections. So let's now start coding. To code, go to code, click on the arrow down, text, continue, select all of these and delete it. Two of our libraries into the code, so let's include hash, include servo.h. So it's a capital, and once again we can copy this line and paste it to the next line and say that it's keypad.h. So So that's it. Now let's name our servo motor as the servo motor, or you can even call it the micro servo or whatever the name that you prefer. So I will just call it the servo motor. So servo motor, and let's not forget the semicolon. And now we are going to define a character called char. That's the short form of it. So character becomes char, and it's char star password equals ABC. So this is our sorry. So this is the password that we have for our door protected system here. So char is a character that we are defining. So not like an integer here this time. So it's going to be a character which has three letters in it. So that's A, B, and C. So whenever you want, depending on whatever the password that you like to put, you can change that the particular password. Don't forget your semicolon, and uh, let's let's define the initial position for your servo motor. So it will be int position 0. So this means that initial position of your servo motor axle is 0. So int is not initial, kids. Remember, int is because it's representing the value as an integer, whereas in the previous line number 5, the value is being represented as a character. So that's why it's char. So here it's int. So now let's define how many number of rows and number of columns are existing in this keypad. So this is all before the void setup, so we can just keep on declaring and including stuff. So we'll be using const and say const by rows equals 4, const by. So simply what these two lines mean is the constant number of rows is 4 and the constant number of columns is 4. So why we are using the word byte there is because byte is a data type in Arduino, which can store 8-bit of unassigned numbers. And now let's tell the Arduino board what these columns are and what these rows are. To do this, we will be having 4 sets of curly brackets and another one there. And here it's very easy. We are going to have so let me show you the structure of it so that it will be easy for you to even do it alone, like do it. So for a change, it will be the comma, and similarly, you can just copy paste it. Right. So this is it, and what's going to come exactly here is the numbers and the letters and the symbols which are on the keypad. So let's drag it a bit more further down so that we can see the numbers well. So here it's going to be 1, there are 2, 3, and here it's going to be an 8. So here it's 4. So just as how it is, you just type it there. 4, 5, 6, and B. So we have C there, we have D there, and we have the hash. So I'll just copy paste the hash from here. What else? We have 0, we have star. What do we have here? 7, 8, 9, 7, 8 and 9. Right, so this is it, and we will not be using this comma right there, so that's it about. So let's type byte call pins calls and 5432. So it's 5432. Now let's initialize the variable by using the mapping function, which we have done like several times. Let's initialize the variable now and start typing keypad, and then again it is being verified as keypad, and it's going to be mapped always when the map function is being used. We have learned that there are 5 values that it can be mapped with. So here the first one will be the key number, the make key map key, and then a row pin, a column pin, and the rows and the calls. So rows and the calls will be as to what we have defined here. Let's tell the Arduino board to which pin numbers are the LED is connected. So let's say int. So we can say int red pin lock 12. That's because it's connected to pin number 12. As you can see the orange connection over there. So same way we can say for the so it's the red connection, and we can call this for the green connection. So it's going to be green pin lock and 13. So green will also have the G in capital and pin number 13. Void setup. Now let's start with the void setup. Void setup, and have your brackets and start. So let's use the pin mode function. Green pin, which will indicate the unlocked position of the system, is also an output, right? Not forget to mention the uh, pin number that our servo motor signal pin is being connected to. So let's say servo motor dot. So let's say servo motor dot attach to 11. So we have to make sure that the locked position is always true when the system is working. So this means that the character that you're going to choose on your keypad when it is a particular symbol is going to be locked. Sorry. Key equals to a star. So this at the vertical bar, this is the OR operator in the Boolean logic gates. So which means whenever the input is a 1, you get an output of 1. So that's the easiest way to remember the truth table for the OR operator in Boolean expressions. So once we have said that, we can also say if it is for the star, or if the key is equal to, say, another symbol like hash. Another symbol like hash. Then let's close the bracket and say the position of the servo motor has to be locked. So locked position becomes true. We can have the semicolon right there. What if the key is the correct password? So if equals 3, and this means the number of digits that we have used for the password, that's ABC. So if it is correctly showing 3 digits at the minimum way of recognizing the password, when it should give the correct password with 3 digits to unlock the system, but having it with 3 digits, you could also say that the locked position is false, so it's not locked at the position as such. So we can type it this way, open brackets, and say locked position is false. So now you could see the lock position that we have used, true we have used for the above case scenarios of if statements, but here we have used the fault state of it. So now we can close the bracket and have a delay of about 100 milliseconds. So let's have a delay of 100 milliseconds. So this is again delays we are having for the program to refresh. Now as you can see, it has gone through a lot of steps, right? So that's why we are having a delay right here. When the system is in the lock position, what are the lights, what are the LEDs, the angle of the servo motor that has to be implemented. So we very well know that the axle of the servo motor can take from 0 to 180 degrees. Here also we can come up with an if statement saying if locked lock position in lock, make sure that it is simple, and make sure at the end we have 2 more curly brackets to cover. And kids, this is it about the whole code. And since it's a long code and it needs a lot of revision and going through for it to get perfect, I have made it proper with those major changes that I have pinned out for you here, and also with the semicolons and some brackets as well. So I recommend all of you to go through the document that is attached with the code as well, because this is not like the other codes which can be simply get it right at once. But make sure you go through all of them over and over and get it right and simulate your circuit and see how well it works. Right, so let's see when ABC is pressed that whether we get the green LED on. Okay, so let's keep it somewhere there so that everything is visible. So press A, B and C, and you could see how the green LED lit up. So press on the star and you could see how the system got locked, right? Or you could even press, let's have it on again, A, B, C. System is on, and even if you press on the hash, the system gets locked. So kids, this is it about our password protected door lock system. I suggest you all to thoroughly work on this over and over and really get familiar with this plus the code, which is very important, because without the code we cannot simulate this. Thank you kids. I hope all of you understood and learned something from today's session. Until next time, see you later.